with another problem which is based on definition of hyperbolic function. So guys, for that, here we have to prove that 16 hyperbolic cos raised to 5x is equal to hyperbolic cos 5x plus 5 times hyperbolic cos 3x plus 10 times hyperbolic cos x. Now guys, the question is how to get this value, because if you observe the left hand side, then there you can find the power of hyperbolic function, that is hyperbolic cos raised to 5, whereas on the right hand side we have multiple angle, that is instead of x we have 5x, we have 3x, and in the end we have just x. Now the question is how to convert that power of the hyperbolic function into the multiple of angle or multiple of that theta. So how to convert that? So it's very simple. I'm just going to use the identity of hyperbolic function which will bring this result. So for that, on the left hand side, instead of hyperbolic cos x, I'll put the formula of hyperbolic function which is given by the great scientist Euler. So I'll use that Euler formula to get the value of hyperbolic cos x. So here we all know that the value of hyperbolic cos x is e to the power x plus e to the power minus x whole upon 2. So guys, this value I'll be substituting in the left hand side. So on the left hand side I want hyperbolic cos x to the power 5. So here I'll take fifth power on both sides. So this will become hyperbolic cos raised to 5x equal to, and on the right hand side we'll get this whole term raised to 5. Now guys, on the left hand side we don't have to do many things because already we got the left hand side, only 16 is remaining, which I'll be multiplying both sides by 16 in the end. Now to get the right hand side I have to expand the right hand side. So on the right hand side here, since the power is 5 and I know that in school you have learned till raised to 2 or maximum raised to 3. So you know the formula till cube, but most of the student, or I would say that none of the student know about how to get raised to 5. But guys, I guess in diploma or in the lower standard like 11 and 12 standard, you must have learned about binomial theorem. So guys, I am gonna use the binomial theorem on the right hand side. So what binomial says? So I'll write down the formula of binomial theorem and then we will be applying that binomial theorem on the right hand side. So according to binomial, this a plus b whole raised to n is given by a to the power n plus nc1 a to the power n minus 1 b to the power 1 plus nc2 a to the power n minus 1 b to the power here n minus 2 b to the power 2 plus so on, and here in the end you'll get last term as b to the power n. So guys, I think I don't need to explain this formula, still I'll tell you in short. So here the first term is a and therefore the first term of the series is a to the power n, and if you'll see the second term, then it is combination, that is nc1 a to the power n minus 1. That means this power is getting reduced by 1. In the third term you'll get a to the power n minus 2. It means this power is getting reduced by 1 in each and every term. Now similarly, if you observe the second term which is b, then here the first term is b to the power 0 and we know that b to the power 0 is 1. So I am not written that b to the power 0. Now guys, that power of b will increase by 1. So in the second term we are getting b to the power 1. In the third term we are getting b square and so on, and in the last we will get b to the power n. So this is how a is reducing and b is increasing, and at the same time the combination is increasing, that is nc1 nc2 and so on. So the last term would be ncn, and we all know that ncn is 1 and hence I have not written that term. Now guys, I will use this formula to solve this above function. So here a is e to the power x, b is e to the power minus x. Now you must be thinking, what about 2? So guys, this 2 is a constant and we know that 2 to the power 5 is 32. So I'll be taking 1 upon 32 outside the bracket. So here we will get value as hyperbolic cos to the power 5x equal to 1 upon 32, which is outside the bracket. Now let's start. A is e to the power x raised to n. Now n is 5. So guys, this will become e to the power 5x, because e to the power x whole raised to 5 is e to the power 5x. So again I'll tell you the identity which I've used here, which is a to the power m whole raised to n is a raised to mn. So here it was e raised to x whole raised to 5, and that will be e raised to 5x because these two exponents will multiply each other. Plus, next term is nc1. Now guys, here my n is 5. So this will become 5c1. Now if you have the calculator, you can calculate that value with me. So 5c1, if you enter it into calculator, you will get value as 5. So here I'll straightforward write 5. Next, a to the power n minus 1. Now guys, what here you'll do is, you don't have to calculate every time. Just see a which you have written in the first term and just reduce that power by 1. So e to the power 5x will become e to the power 4x. So here e to the power 4x. Now at the same time, this b to the power 1 is nothing but your b. So your b is e to the power negative x. So here I'll write down that term e to the power minus x plus, now next term is nc2. Now here n is 5. So we'll be calculating 5c2. Now the value of 5c2 is 10. So here I'll straightforward write it is as 10. Now guys, here again I'll reduce the power of a, so that will become e to the power 3x. I'll increase the power of b, that will become e to the power minus 2x plus, next term is nc3 and n is 5, so 5c3. So guys, the value of 5c2 and 5c3 is exactly same, so again that is 10. Reduce the power of a, increase the power of b, so that will be e to the power 2x and e to the power minus 3x. Now again repeat the process, plus 5c4, which is again 5, reduce the power of a, so e to the power x, increase the power of b, e to the power minus 4x plus 5c5 1, a to the power, now if I reduce it, it becomes e to the power 0 and e to the power 0 is 1, so I won't write, and this term will become e to the power minus 5x. So guys, here we have expanded the above term by using binomial theorem. Now what is next step? So here we'll simplify the terms, like here e to the power 4x into e to the power minus x. So it's e to the power 3x. So again I'll be using law of indices to simplify these 4 terms. So here we will get, it's equal to 1 upon 32. Now first term is e to the power 5x as it is. Second term 5 e to the power 3x. Now next term e to the power 3x into e to the power minus 2x. If we add this, we get e to the power x. So that will become 10 e to the power x plus, here we will get 10 e to the power minus x plus 5 e to the power minus 3x. So here 10 e to the power minus x plus 5 e to the power minus 3x plus last term is e to the power minus 5x. Now guys, after this we'll be taking pair of similar exponent terms. So here you can observe that the first term is having exponent as 5x and the last term is also having exponent 5x but negative 5x, but still I'll consider the magnitude. So I'll take these two terms together. So this will become 1 by 32 e to the power 5x plus e to the power minus 5x. Next, here e to the power 3x and e to the power minus 3x, and with both this term we have the coefficient as 5. So I can take that 5 common. So 5 will come outside. Here we will get e to the power 3x plus e to the power minus 3x plus 10 e to the power x plus e to the power minus x. Now guys, if you'll see the two terms, then it is exactly matching with the definition of hyperbolic function. So I'll go back there. So here I had written the definition of hyperbolic function, which is hyperbolic cos x is equal to e to the power x plus e to the power minus x whole upon 2. So guys, in this formula, if I divide it by 2 and if I see the exponent, then it is 5x. So by applying this formula, I can get hyperbolic cos of 5x. So similarly for next two terms. So what I'll do is, from this 32, I'll write down this as 1 upon 16 into 2, and I'll shift that 2 inside the bracket. So that 2 will go inside and it will divide each and every term. So this first term will become e to the power 5x plus e to the power minus 5x whole upon 2, which is nothing but hyperbolic cos 5x. So here again I am applying the definition of hyperbolic function, plus 5 times. Now that 2 will come inside. Here we will get hyperbolic cos of 3x plus 10. Here that 2 will come inside and that will become hyperbolic cos of x. And guys, if you see this result, then it is exactly matching with our question. So whatever that was asked in the question, we have proved here. So here we got the result which was asked, and here we had used the definition of hyperbolic function. So guys, I'm sure that you like this video and you understood the method how to derive this result. And if you want to access such more videos, then do visit to ekeeda.com, where you can get knowledge of all mathematics of engineering. Thank you very much.